the graph, it's in terms of x.
Oh.
Got a 39, 53, and 79.
Wow, there we go, there's a start. Anything else? All right, 69, what are we doing? Oh, fabulous. All right, so we want to write the expression in terms of x, right? Tan of the inverse cosine of x in terms.
Mostly.
All right, so did you look at it and not do anything? Ah,
I
okay.
tried, and I didn't.
What did you try?
I can't remember.
Inverse cosine of a what?
Tangent.
I'm trying making a triangle with x over 1.
Perfect. They don't give you a domain here. We're just gonna go first quadrant. So cosine is x over 1. So this is being represented by that picture, which is some angle which we actually aren't going to need, because once we fill in the third side, then we're going to be able to figure out tangent. So if you call this, I guess, y, so we want to figure out what y is. So x squared plus y squared is 1 squared. So again, we want an expression for y in terms of x. So if we bring our x squared to the other side, y squared is 1 minus x squared. Y is 1 minus x squared. Oh, whoops, dude. Square root. If we're in the first quadrant, then it's going to be the positive square root. So y is the square root of 1 minus x squared. And then tangent is y over x, so it's just that radical over x. Tangent is the y portion over the x portion, so we get the square root of 1 minus x squared over x.
Okay.
Can you get rid of the square root?
Like by square rooting 1 and square rooting x squared.
Okay.
The algebra gods are coming lightning bolts at you. Sorry. Okay. What's 9 and 16?
4.
What's 9 and 16?
Oh, 9 plus 16?
Okay. We get 25. Square root of 25.
It's 5.
You want to take this and say, oh, that's the square root of 9 plus the square root of 16, which is illegal because this is 3 plus 4, which is 7. It doesn't work. Yeah. You cannot, now if you had, and 1's not so exciting, but if you had the square root of 4x squared, if you had multiplication going on there, or even division, that's when we are allowed to square root both of the pieces individually, but addition, subtraction, no. However, we want to take that, I don't want to take it with a grain of salt, but grouping symbols do make a huge impact, because if we have the square root of 1 minus x quantity squared, that's a different story.
Mm-hmm.
Yeah, so the order of the operation of the subtraction and the square root, they're not commutative. You can't just interchange the order. So you wanna, the expression says subtract first, then square root. You want to square root first, then subtract, and they're not commutative the same, doesn't work. All right, so that's 69. 39. So let's see, Patrick, 39. We have the inverse sine of the tangent of pi over 3. All right, so do you draw your angles to figure out the tangent of pi over 3?
So, yeah.
Yeah? All right, so pi over 3 we're thinking is 60 degrees. So if we draw our triangle in the first quadrant, 60, we're going to label it root 3, 1, 2. Everything's positive. So now there's our picture, and now we're just going to figure out. So, again, okay, so the tangent of pi over 3 is a ratio. Okay, so this is root 3 over 1. Okay, now what we need to do is say, it could be easy to say, well, the answer might be pi over 3, and the reason why it's not is I can't use this picture. Or I can't take the sine ratio, which is root 3 over 2. Because now I've got the sine ratio is root 3 over 1, totally different picture. Sine is y over r, so this is root 3, this is 1, Pythagorean theorem. Wait a minute. Oh, what's wrong with this?
The hypotenuse isn't along the side.
Hypotenuse isn't along the side. It doesn't exist, can't do it. I was like, wait a minute, that's not right. Okay, so that's what's up with 39.
So that's the answer, is
Yeah,
doesn't exist?
yeah, not possible. What did they write in the back of the book? Does not exist, probably. 53. Did I copy the problem right? I'm sure. Yeah. All right, 53. Oh, fabulous.
Says not defined.
Okay. First of all, we want to be careful we don't do things we're not allowed to do. Okay. You're looking, it's 2 times the inverse sine of 4/5, and you see, you could possibly see 2 times 4/5 and say, oh, 8/5. Don't do that, okay? Where this is 2 times, what does this represent?
Ratio.
The 4/5 is the ratio, and when I take the inverse sine of the ratio, what do I get?
Angle.
An
Angle.
angle. So this is really representing the sine of 2 times some angle. And the sine of 2 times some angle is a formula with respect to the angle. Because I don't know anything about the double angle, but I've got information about the angle. And if we call it theta, then we've got information about theta. We know that the sine, the inverse sine is 4/5. We can start asking ourselves, where am I supposed to draw 4/5 before I just go draw it for you? What quadrant are we drawing this in?
1 or 2.
First.
Not 2? Why are we not 1 or 2?
Because it's not negative, like that also be negative.
We
But, well, isn't
go 1 to 1. So in order to talk about the inverse trig function, we need the horizontal line test, we have to restrict the domain.
Oh.
Sine is restricted to quadrant 1, quadrant 4. Quadrant 1 is when the ratio is positive, quadrant 4 is when the ratio is negative. So we are
Oh, because it's
absolutely
positive.
drawing in quadrant 1. Okay, but we're not also going to draw in quadrant 2, and it's because the inverse trig function is in the problem, which is going to be a little bit of a distinction between what we're doing today. So, but sine is 4/5, so we can do Pythagorean theorem. If it's okay, that's going to be a 3. Okay, so this angle is right there. Now, be careful, don't ignore the 2, because you might say, oh, the sine of this angle is 4/5. But we want the sine of 2 times the angle, and if we use our formulas, it is 2 sine of the angle cosine of the angle. So we've got 2 times the sine of that picture is 4/5, and the cosine of that picture is 3/5. Does that make sense? Patrick, are you good?
Yeah.
Slap a 1 underneath this. Oh, I felt so bad. Justin, how do you multiply fractions?
This is straight across.
Do I need a common denominator?
I don't.
What you did on your test? You don't. You were probably cursing me. I can't believe she's making us do this. Anyway, I'm pretty sure we should do something else. But it's that nice, oh, get the nice black marker and neat handwriting. Okay. So it's 24/25. 79. We want to graph. Nobody needed any one of those equations? All right. 79. Y equals 2 times the inverse cosine of x. All right. And we're supposed to draw the graph, use stretching, shrinking, translation procedures to graph each equation. So we are going to graph. With respect to all of our transformations that you all remember from college algebra, or what does that 2 do to the function?
Stretches it.
Stretches it. It's going to double the height. Okay? So we're going to graph y equals the inverse cosine of x, and then we're going to double the height. Okay, so I don't necessarily have that memorized, so I'm going to say to myself, okay, let's break it up into pieces. So the inverse cosine is reflected over the line y equals x. So if I graph y equals cosine first, get my restricted domain, reflect it over that line, then I will have my red graph. Does that make sense? So cosine does this. We restrict the domain to make it 1 to 1 in this window from 0 to pi. Okay, so this is pi, this is 0, this is going up to 1 and down to -1. So now what we're going to do, we're going to color. All right, we're going to, so that blue portion, here, let me not dot it. That is the restricted domain of the cosine curve that we are going to reflect. Okay, so this is cosine. We want inverse cosine, so we're going to reflect it over the line y equals x. Okay, so this upper part is going to come down and it's going to be over here. Oh, well, yeah, we'll draw it in black. This part here is going to flip up, and so It's going negative, which means I'm gonna go negative. Okay, cosine, I think cosine is the weirdest one to reflect over the line. Sine is easier, tangent is easier. Here, if you, and I did this Wednesday, if you change your unit, or if you switch your y-axis labeling to become your x-axis labeling, now I'm going from 1 to -1. And my x-axis labeling becomes my y-axis labeling, now I'm going from 1 or 0 to pi. I mean, that could help. Okay. So now we're focusing on the black graph. The black graph is the graph of, oh, I should have drawn it in red because now I'm going to draw that in red. Sorry. Final answer, red. Now, are we shifting it? No, we're stretching it. Okay. So where I hit the x-axis here at 0, what's double 0?
0.
Still 0. We cross the axis through right here at halfway between 0 and pi over 2, and if I double that, now I'm twice as tall. And I was ending at pi, so now I'm going to end at
2 pi.
2 pi. And our width is going to stay the same, so don't stretch it out or shrink it. We're going to be right here. We're going to cross and swoop down. So that I don't have to memorize things, or that you don't have to memorize things, if you sit there and kind of work through the process and just say, okay, I'm going to do this, I'm going to remember this is my restricted domain, I'm going to reflect the graph, and then I'm going to do whatever they want me to do to it, then less memorization.
So if we graphed 2 cosine verts and then reflected that would be wrong? Or would it work?
It's not going to work because that's what I was kind of pausing to think about in the beginning.
Yeah.
Okay, 2 cosine is going to do that.
Yeah.
And if I reflect this, no, because this is going to be up at 2, which means I'm going to be out on the x-axis of 2. So it actually will increase the width.
So it increases all of it.
It would
versus
increase
just
the width, yeah. Yeah, I would just say, let me graph my trig function first, then do the transformation to it. Because it's kind of like the same exact thing as what we're kind of doing here. If we reverse the operation, the order of the operations, it doesn't compute the way we want it to.
Yeah.
All right. Okay. We are going to be dealing with section 3.6. Okay, so if you don't have a tendency to take notes, you might want to take notes.
That's how bad it is?
It can get pretty intricate. Okay, we are doing 2 days of it, so there are some equations that we're going to be dealing with on Monday. But you can give yourself a pat on the back that you're here today, so it's exciting. 3.6 solving trigonometric equations. All right. Algebra class.
No.
I know. You love algebra. What is the difference between solving the equation x squared equals 4 versus just square rooting 4?
It's in relation to something else?
What is the sign of variable?
The
Huh?
What is the sign of variable?
the equation has 2 answers.
The equation has 2 answers. And if you remember, probably your algebra teacher bashed it into your head. When you square root both sides of an equation, what do?
Put a plus in
Plus minus. Because we know that square square 2, you get 4, square negative 2, you get 4, so that we get all of the solutions to the equation, it's plus or minus. However, embedded in the definition of the square root function, it's the principal square root. The square root of 4 is the positive value that you can square and get 4, which is 2. Okay? Over here, we have an equation. Over here, we have an expression. The inverse function of square rooting has one answer. Okay? Why am I emphasizing that from algebra? Is because guess what we're going to do?
Equations.
Oh, let's go degrees. And maybe not so much with this, but possibly, so this can be question A, but possibly question B, you might say, well, wait a minute. Okay, so we're going to solve. We want all the angles. Now, there are an infinite number of angles that make this true, right? If we just kind of think of the sine curve. Yeah. Okay, here's root 3 over, negative root 3 over 2. Here's negative root 3 over 2. And so I want all the times when is the sine curve going to equal negative root 3 over 2, negative root 3 over, there's an infinite number of answers. However, we are going to find the answers that lie within one revolution of our angle measures from 0 to 360. When will the sine be negative square root of 3 over 2? All right, so first of all, what are we going to focus on? When is sine negative? Or maybe what quadrants is sine negative?
3 and 4.
So we have two answers. One of them is a third quadrant angle, and one of them is a fourth quadrant angle. Okay? Once we determine where are we going to have answers, then we can go ahead and label our sides with respect to sine, which is y over r. So we get negative root 3 over 2, negative root 3 over 2. You can use Pythagorean theorem, or hopefully you now recognize that this is a special ratio, and the third side is 1. This is negative. Technically, we don't necessarily need it, but if we just get in the habit of always labeling negative things about that value. We want the angle. So we're looking for our reference angle here. What's our reference angle? What's opposite root 3?
60.
60. Is my answer 60? No, I want the angle that is in the third quadrant with a reference angle of 60. And we're getting positive angles. And besides the fact that this tells us I want angles in one revolution of our angles, and the fact that they're positive, it also tells them what kind of angles are you giving as answers? Degree measures. Okay, so we are going to be careful about that. If we had from 0 to 2 pi, it's understood you're going to give your answer in radians. Okay, so we want that angle in the third quadrant, which if you say, well, this is 180, and if I add 60 to it, x is 240. Okay, well, oh, wait a minute, hold the phone. There's an angle in the fourth quadrant, which also has a reference angle of 60. And if we do that rotation all the way around and stop short of 360 by a unit of 60 degrees, then we're at 300. I had two angles. sine ratio 1/4. We can say, well, 1/4 is going to be here, it's going to be here. We're only wanting one revolution, so we're actually just looking for these two. If we draw a picture, we're going to say, where do I draw?
The opposite of the first.
First and
Second.
second. Sine is positive in first and second. Oops, that's a wonderful shirt. Okay. And we can label our ratio y over r. So we got 1, we got 4, we got 1, we got 4. Is anybody having problems? If you do the Pythagorean theorem, what do you get? Okay, is this special?
No.
Can we figure this out? We can't. So what are we going to use?
Calculator.
You're going to need our calculator. This is not a special ratio, not a special, or a ratio of a special angle, however you want to phrase it. Special ratio. So therefore, we need our calculator to solve. Okay, this is the reason why you're going to have your calculator on your test. Okay, I'm not going to take the sine of 1/4. 1/4 is my what?
Ratio.
Ratio. And I want the angle. I take the sine of angles and get ratios. If I have the ratio, what can I use to get the angle?
Inverse.
The inverse sine. Oh, thank you for saying that, because I always forget to mention it, and you guys go to calculus, and I probably look like a goofball. All right, so we're going to take the inverse sine of 1/4, because this is my ratio, and I'm going to get as an answer my angle, which is what we need to solve the equation. This trig book exclusively uses this notation for the inverse sine and the inverse cosine, inverse tangent. There is another notation, it's called arc sine, and it's the same exact thing. Arc cosine, arc tangent, and that just is the same exact thing, and you will probably see this in your calculus book. More? I don't really know, more or less. I don't teach calculus out of this book here, but you'll see it in your calc book. I'm actually kind of surprised they don't do it in the trig book, but what can I say? So it's the same exact thing. Okay, so when you get to calculus and your teacher says arc sine, don't freak out. They'll probably remind you. They're probably used to their trig students not seeing it. Anyway, so this is where, before we punch up, we're going to make sure that we're in our right mode. So in your calculator, depending on your calculator, your scientific calculator, you might have a DRG key. You might, and this goes degrees, radians, and gradians. I think it's a T. Gradients are another angle measure that we're not going to deal with. So you might also be able to access changing from degree mode to radian mode through a mode key. Most of the time, if you've been using a scientific graphic calculator, if you used it in high school and you did this, so here we are solving in degrees. So we want our calculator to be in degree mode, and a lot of times in your calculator display, you probably didn't even look at it so much, but it says DEG up in the top of the display. It might also have radian, you know, so if it doesn't say that and it says RAD, then you're in radian mode, and I would be solving, when I did inverse sine of 1/4, I would figure out the radian measure comparable to what we've got drawn there, but just not in degrees. So I have your textbook doesn't have you use calculators. with radians, which I think is like a flaw. And so in your problems, there are two problems that I had you solve in radians. So that's the reason why it says next to number 47, solve 0 to is less than or equal to x is less than 2 pi, and the same thing for problem 59. Those answers are on that half sheet of paper that I gave you at the very beginning of the term for, actually, yeah, 47 has some decimal answers and some pi answers. All right, so we are going to punch this up. So if you have your calculator or your cell phone, let's see, where am I? What am I in? Degrees. All right, so we're going to do inverse sine. Please don't try to always do it in degrees and convert it to radians. It's just using more time and more, I don't know.
Brain matter.
Brain matter, yeah. Okay. Hopefully you got 14.47. A lot of times they say round degrees to the nearest tenth. So if we have 14.47, which is the 10th place?
4.
That's the 10th place. What's the 7? Hundredths
Hundredths.
place, thousandths place. Okay, so we're going to round to the 4, which means we're going to give our answer as
14.5.
14.5. Okay, you're like, well, I didn't need to draw. Not true. We didn't need to label. But it is still helpful for us to draw. The calculator, we had a positive ratio. The inverse sine function is defined for positive ratios in the first quadrant. The calculator gives us the first quadrant angle. You got to work for the other one. There are 2 answers to this problem. The calculator is only going to give you 1. Okay? But this angle right here is 14.5. What's this angle right here? 14.5. How am I going to figure out the rotation of the angle I need that's going to answer this problem correctly in the second quadrant?
180 minus.
We're just going to
14.5.
subtract 180 minus, and I always just go back to this unrounded one. It's not going to be so bad, but if you have to do anything else with that, so 180 minus the 14.47 blah 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 will give you like 165.5, I think. Make sure when I subtract these correctly, I do it right. So we have 2 answers. Okay. The difference, so why did I go into the algebra class, the equation versus the expression? We're solving the equation. That equation has 2 answers. We are using the inverse trig function, which is an expression, which does give us 1, and we need to work for the other. Okay? Similarly, we just finished that section. This has 1 answer. It does not have 2. It has 1. First quadrant angle. Okay, so just kind of get that in perspective. If you slacked and you didn't do 3.5's homework between Wednesday and today, that's fine. Just kind of do it over the weekend. I probably made it due on Monday, didn't I? If I was smart, I did. It's not due till Wednesday. Please do not wait till Tuesday night to do this. All right. If you have a textbook and you want to open up your textbook to page 278, I can entertain some questions that you might not like to look at, and we can solve what looks ugly. Lauren, what looks ugly? 10? Oh, look at that.
What does it?
10. We're going to solve. Make sure you go and look at the directions at the top so that you know your red box here. Okay, so here we're going to solve over the interval from 0 is less than or equal to x, which is less than 2 pi. So this says we're going to give our answer as radians. Okay, so don't ignore that. I know sometimes we ignore directions. All right, so what do we have going on here? We have secant squared x plus the square root of 3 secant x minus the square root of 2 secant x minus the square root of 6 equals 0. That was lovely.
You're missing a 2.
I'm missing a 2?
And minus 2 square root of 2
That's what it's
secant
on.
x.
You're combining number 10 with number 9.
Sorry, I'm looking at
What's that?
9.
Which do I give you? I probably do.
You can do that one as well.
No, I don't actually.
Oh, no.
All right. Here, hold the phone. Let's, if you were given that equation, what do you think you might want to do? Factor. We are going to expand our brains and we are going to use all of our factoring capabilities now with trig functions. So let's go back to number 10. If you've got 4 terms, what might be a viable factoring method to use? Factor by grouping. And most of the time, try grouping the way it's written. Just try grouping the first 2 and the last 2. So out of the first 2, secant squared x plus root 3 secant x, what can I factor out? Secant x. Okay, so if I factor out secant x, I'm left with secant x on the squared part and plus root 3, yes?
Yep.
All right. We definitely, when you're factor by grouping, factor out that symbol, that negative sign. So we're going to factor out a negative what?
2
Square root of 2. Let's factor out negative square root of 2. So we're going to have to think a little bit on that square root of 6. So if I take that out, we get secant x. You could kind of cheat a little bit and say, well, if it's actually factoring by grouping, root 3, oh yeah, if I pull out the square root of 2 from the square root of 6, which is kind of weird, but if I pull out a negative, it's plus, and if it's going to match up, what we can do is just put it there and then just double check that this multiplies to provide that. So the negative square root of 2 times the positive square root of 3 is negative square root of 6. So it does totally factor by grouping. Okay, now remember, our next step with factor by grouping is what do they have in common? They have this expression in common. When I pull it out, I'm left with secant x. When I pull it out, I'm left with minus root 2. Okay, we do not end up with secant x plus root 3 squared. Okay, it just ends up being like that. You've developed a pattern when you just have variable x's, but now I've got trig functions, you might be like, whatever. All right, once we have a factor, what do you do?
FOIL.
No. Okay, if we FOIL, what's going to happen?
Come back.
We're going to go back to where we were. We factored, and conveniently, we are so excited about this. Before you factor and you're solving an equation, you're always going to make sure it's equal to 0, because then, if two things multiplied to be are equal to 0,
Did you divide one out?
Let's not do that.
Okay.
If we know that A times B is equal to 0, what do we know? Have
One
to
of them
have
is
it.
0.
One of them's gotta be 0. So this is where we're gonna take this, set it equal to 0, take that, set it equal to 0, and you can't do it so much in your head. Like you were probably a pro at your plain quadratic equations. So we take that, set it equal to 0, and more solutions can come from if this expression is equal to 0. Secant x minus the square root of 2 is equal to 0.
Mm-hmm.
All right? So, secant x, bring the square root of 3 to the other side. Secant x is equal to negative root 3. Secant x is equal to positive square root of 2. Do you like secant, or you want to convert it to cosine?
I don't like it.
Huh?
I don't like it.
You don't like secant? So this is over 1. So if I converted this to cosine, which is 1 over secant, right?
Mm-hmm.
So we just take this reciprocal of both sides, kind of.
Mm-hmm.
We get 1 over root 2. I kind of like that ratio. It's fine. Don't bother rationalizing it. Leave it alone, because that's not our final answer. So the same thing over here. Cosine x is equal to negative 1 over root 3. All right, so we've got cosine x is equal to negative 1 over root 3, and we're also solving cosine x is equal to positive 1 over root 2. Where is cosine negative?
Quadrant 4 and
2.
So we can remember all seniors turn crazy. We can remember that cosine is x over r, so that x, where is x negative? Here cosine's positive in the first and the fourth. All right, x over r, so we got 1, we got root 3. Have you ever had root 3 on a hypotenuse before?
No.
And be careful about labeling that too, because it's not 2. What are we doing with this?
Quadratic.
Calculator. Okay, so it's not special. It's not 1, 1, root 2, and it's not 1, root 3, 2. So we have to use your calculator. Okay. This one is x over r. So 1, root 2. This one actually is special. You shouldn't need your calculator. It's a 1 and a 1 and a root 2, which makes it, what's my angle?
45.
45. Do I want degrees? Do I want radians?
Radians.
Radians. So what's 45 degrees in radians?
Pi over 4.
Pi over 4. Which means that this angle here is pi over 4 short of 2 pi, which in terms of fourths is 8 pi over 4. We are going to give positive rotations because our domain that they gave us for our equation is starting at 0. So we are going to say from positive rotation, so hopefully you're like, oh, that's just 7 pi over 4, that's sweet, I got that. So far we've got these two angles. We still need that one. All right, so what are we going to do on our calculator?
Inverse.
Inverse cosine of negative 1 divided by root 3. We're going to have lots of parentheses going on here. So we got the inverse cosine. Make sure you do not take the cosine of it. So we need the inverse cosine of negative 1 over root 3. And don't try to make this a negative exponent and flipping that fraction over or something like that. That'd be crazy. All right, inverse cosine of negative, make sure you use your minus key, not your subtraction sign. 1 divided by the square root of 3 And, oh, my calculator was okay. Oh, guess what I wasn't in?
Radiant.
I wasn't in radian, I got 0.9999, so let's go back. I gotta put myself in radian mode. Enter, go back and redo that. Alright, so I got let's see, the directions say, they don't. Huh, okay, so we'll just do it to the nearest hundredth. Do they do hundredths or thousandths later? Nearest tenth of a degree, oh, that's right, oh, anyway. So let's just do it to the hundredth. So, 0.8379. All right, so our angle for x is 0.84. No, it's not.
Yeah, I got 2.
Close your parentheses.
I did.
Oh, dang it.
Thousands.
What happened? What's going on? Oh, I didn't do inverse cosine. Dang it. Okay, make sure you do inverse cosine. Inverse cosine. Minus 1 divided by square root of 3. Close your parentheses just to be on the safe side. All right, hit enter. 2.1862. 2.1862. So we're going to give it to the hundredths just because I decided. So we're going to say x is approximately 2.19.
This is in radians.
Now, that is radians. Be careful. Guess what your calculator gave you? It gave you that rotation. So inverse cosine is quadrant 1, quadrant 2. So it told you quadrant 2 angle in radians. 2.19. A couple different ways we can get the third quadrant angle. Okay? What can we do?
It didn't tell us the reference angle.
No, it's not telling us the reference angle because I'm not in the first quadrant. You know what? Guess what would happen if I took that negative out?
Then it tells the reference
It
angle.
would totally tell us the reference angle. Technically it would be over here, but it would be the reference angle. Okay? But, so you can do that. A couple different ways people can now proceed to get the second angle. I don't normally think about this, but I know other students do because I see it on their test, is they'll say, well, this is 2.19. All the way around is 2 pi, so they'll take 2 pi and subtract. Make sure you use that entire decimal, 2.1862. So you're going to make use of your ANS key, answer key. Some calculators have an answer key button. Sometimes that is accessible as a second function from your plus minus key. So we can say 2 times, use your pi button, do not use 3.14. Use 2 pi and then subtract your previous answer. Okay, let's see, what do we get? 2, I don't think you need the multiplication symbol when you're saying pi minus the answer. So I get to the nearest tenth, 4.10. Is that what you guys got, if you're doing it? Okay, we could also have said, well, this is pi, so we could take pi minus 2.1862, blah, 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 and that would actually tell us our reference angle. And then take that number and add it to pi. So you're finding the difference between pi and the angle you've got, and then that's the same exact unit measure that we're going to have to use past pi. So then we could take this answer and then add it to pi, and we should end up with that. All right. We are out of time. The name of the game is factoring. Yes.
cause I know I didn't bring it, but I know my calculator doesn't have an inverse sine button.
Do you have a scientific calculator? Is it a financial calculator?
Never mind, it probably does, never mind.
Never mind.
We're okay.
Ah,